Today I'm going to talk about word problems that can be solved using trig. The first thing that I have to talk about are degrees, minutes, seconds. Degrees, minutes, seconds is another way of writing decimal degrees. So we need to be able to understand what it means when it says minutes and seconds and how to convert back and forth. So in 1 degree, there are 60 minutes. And every 1 minute is 1/60th degrees. In one minute, there are 60 seconds. So every 1 second is equal to 1/60th minutes. So if I want to convert 5 degrees, 12 minutes, and 25 seconds, and you'll notice how this is abbreviated here. Minutes is abbreviated with 1 tick mark. Seconds is abbreviated with 2 tick marks. So this would become 5 plus 12 times 1/60 plus 25 times 1/3600. That's because in every 1 degree, there are 3,600 seconds. If you put that into your calculator, you'll find that that is 5.207 degrees rounded. Now, if I want to convert decimal degrees to minutes and seconds, it goes like this. I have 46 degrees, and then I have 0.267 times 60 minutes. So that becomes 46 degrees, 16.02 minutes. But now I have a fraction of a minute, which is really seconds. So I can change that to 46 degrees, 16 minutes, and 0.02 times 1/60 seconds, which becomes 46 degrees, 16 minutes, and 1.2 seconds. And I can't break it down any further from there. Angle of elevation and depression, I'm sure you've seen before. The angle of elevation is measured from the line of sight, horizontal, so you're down on the ground looking up, and then I measure the angle. So from the ship up to the top of the lighthouse, this is the angle of elevation. The angle of depression is measured from the top looking down. So if you look at your lighthouse, this time we're going to look with the line of sight horizontal. So you can imagine someone is up here in this lighthouse looking straight out. The angle of depression is what you see when you look down, and this is the angle of depression. A common error is that students look and say that this is the angle of depression, and it's not. Remember that the angle of depression is from the horizontal looking down. Now what you should notice is that if you draw your lines of sight, these are actually parallel. And these angles in here are congruent because they are alternate interior angles. So the angle of elevation is congruent to the angle of depression. I'd like you to try this problem. A monkey is hanging in a tree, 68 feet tall, and spots a banana at 23 degrees angle of depression, at a 23-degree angle of depression. I want you to find the direct distance from the monkey to the banana. Press pause on your video, and when you're ready for the answer, press play again. As you can see, I've drawn the angle of depression from the horizontal line of sight down 23 degrees. And the direct distance is that between the monkey straight to the banana. And we solve this using trig. Sine of 23 is the opposite 68 over the hypotenuse, which is the unknown, and we'd like to find that. Solving for x, x is equal to 68 over sine of 23. Plug that into your calculator, and you'll find that it's 174 feet, rounded to the nearest foot. Next, I'd like you to try this problem. I have a 50-foot wire running from the top of a tent pole to the ground, and it makes an angle of 58 degrees with the ground. If the length of the tent pole is 44 feet, how far is it from the bottom of the tent pole to the point where the wire is fastened to the ground? And the tent pole is not necessarily perpendicular to the ground. Press pause on your video, give it a try, and when you're ready for the answer, press play. Okay, as you can see, this is the ambiguous case. So the only way to solve this is from the law of sines. And I have my wire drawn here. That's my 50-foot wire. And my pole here. And I made sure not to draw it perpendicular to the ground. And I want to know how far this point is where the pole meets the ground to where the wire meets the ground is. So I drew this, and I put my 58-degree angle here, and I set up law of sines. Sine of 58 over the opposite side, 44, is equal to sine of A over 50. I solved, and I found that I had a reference angle of 74.5. You have to remember that sine is positive in both the first quadrant and in the second quadrant. So I found that my angles could have been 74.5 or 105.5, and I filled those in here and here. From there, I found that my other angle in this triangle, my first triangle here, was 16.5. I did that by knowing that the angles in my triangle sum to 180. So 180 minus 58 minus 105.5 is 16.5. Did the same thing over here. I found that this third angle is 47.5. And then I solved these two triangles for x. So I started again with sine of 58 over 44 is equal to sine of 16.5 over the opposite side x. I solved and I found that that was 14.7 feet. When I set up my other proportion, I had sine of 58 over 44 is equal to sine of 74.5 over x. Ooh, that is an error. Let's fix that. So, not 74.5. It should have been 47.5. Let's change that. Sine of 58 over 44 is equal to the sine of 47.5 over x. If you cross multiply and solve, you should find that x is equal to 44 sine of 47.5 over sine of 58. So plugging that into my calculator, I find that x is equal approximately to 38.3 feet, not 50. This is incorrect as well. So be careful when you're solving. Oh, I don't like how I circled that. This part is equal to that. I chose the wrong angle. So 38.3 feet. Now, why are there two options? Well, this is why. Because if you think about your tent and the pole is uneven, you can't tell which angle you're looking at. So from the acute angle, you should see that it is here, and the obtuse angle over here. So my smaller angle over here is going to have a smaller side length, larger angle over here, larger side length. So if you think about this, this is really the 16.5, this is the 47.5. And that is where you get the two different triangles. Next, I need to talk about bearing. There are two different methods of measuring bearing, and bearing has to do with directions. So if you're out in the middle of the ocean, you can't say turn right at the next intersection. So you have to give some kind of direction based upon where north and south are. So if you are measuring the direction from A to B, here's A, here's B, there's two ways of stating this. One is that we measure from the north-south line and we go clockwise, 35 degrees, and then it's understood that you're measuring from the north line. The other way is that you measure the acute angle from either the north or the south line, and you state whether you're going east or west. So this bearing would be north, because I'm measuring from the north, 35 degrees east. Next, I want you to draw this in your notes. I'm still measuring from A to B, but now B is from A, it's southeast. We're going to be measuring, again, from the south line because I want my acute angle. That's my first method. South, 25 degrees to the east. The other method is still measuring clockwise from the north line, always from the north line. Ooh. So if you measure this from the north line here, that angle is 155 degrees, or 180 minus 25. So both of these mean the same thing. Now I've moved where B is again, and I want to state using my two methods what the bearing is from A to B. So at A is where I'm starting, and I want to state with my first measurement, it's always the acute angle formed with either the north or the south line. So I'm going to extend this line down here, and this angle here is 30 degrees. So the bearing here is south, because I'm measuring from the south line, 30 degrees west. Or using our first method, we measure clockwise. That's 210 degrees, 180 plus 30. Draw this in your notes. Now I've moved B over to the left-hand side, and I want to state the bearing from A to B in two different ways. I'm measuring from A, standing at A, and looking towards B. So my bearing here is measuring from the north, 40 degrees to the west. That's the acute angle from the north. The other way, when I don't state north or south, is the clockwise measurement from the north. So the second way would be like this. So 360 minus 40, or 320. So let's use this in a bearing problem. I have a boat. It's traveling on a course north 36 degrees east for 200 miles from a pier. I want to know how far north and how far east the boat traveled. Pause your video. When you're ready for the answer, press play again. So here is my answer. I have drawn my triangle. The boat has traveled from the north 36 degrees east, and I used trig to solve my problem. So sine of 36 is the opposite over the hypotenuse, e over 200, and I solved from there and I got e is 117.6. Then to find how far north it had gone, I used cosine. Adjacent over hypotenuse, I found that it had traveled 161.8 miles north. Here's another problem I'd like you to try. I have two planes. They take off at the same time from an airport. The first plane is flying at 246 miles per hour on a course of 135 degrees. The second plane is flying in the direction of 175 degrees at 357 miles per hour. Assuming there are no wind currents blowing, how far apart are they after 2 hours? Press pause on your video. When you're ready for the answer, press play again. So here's my picture. The two planes take off at the same time from the airport. So I have drawn their first location right here. The first plane is flying at a course of 135 degrees. So measuring from my north line, 135 degrees, my blue line, that's my first airplane. The second plane takes off from the same place, only now it's traveling at 175 degrees, which is this green ray that I've drawn here. And then I want to know how far apart they are after 2 hours. So if the first plane is going 246 miles per hour, after 2 hours it's going to be 492 miles. And the second plane is flying at 357 miles per hour, so it's going to be 714 miles further from where it started. Then I want to find this length. Using the law of cosines, x squared is equal to 492 squared plus 714 squared minus 2 times each of those times the angle in between. The angle in between, ooh, mistake, let's fix it, is not 5 degrees. It is 175 minus 135. So getting rid of that, it's not 5 degrees. It is 40 degrees. My bad. So replacing this, it will no longer be 5, it will be 40. Get rid of that. So we're going to plug into our calculator again. 492 squared plus 714 squared minus 2 times 492 times 714 cosine of 40. And then I have to remember I have to take the square root. So my answer would be approximately, because it's rounded, 462.2 miles. I'd like you to work on the assignment that I've posted online. Have a great day.